Hello everyone, today we'll be presenting our project on optimizing the setup of a bubble CPAP leak detection system. Bubble CPAP is a respiratory device that is used in order to deliver oxygen to neonates and allow them to breathe spontaneously. However, one of the major problems with this therapy is that leaks often occur within the circuit, causing harm to patients. Therefore, there is a need for a device that is able to earlier detect leaks so that they are remedied sooner. This device would be used within a neonatal intensive care unit or NICU of a local children's hospital, and the end users are respiratory therapists and technicians that would be setting up and using the device every day. Shown here is a bubble CPAP device. The main things to note is the distal tubing going from the neonate's face and submerging within the bubble CPAP bottle. Here's an image that shows where the flow sensor is connected within the bubble CPAP circuit. The main components of this device are a flow sensor, a mounted touchscreen display, and the power cables. The primary goal of our project was to standardize the setup process for the bubble CPAP leak detection system in order to, number one, minimize the time that the distal tube and expiratory limb are disconnected, as when these are disconnected, the neonate is not receiving any bubble CPAP therapy. 2, minimize the total machine setup time, and 3, minimize the stress in the respiratory therapist bodies. In order to do this, we observed the process, completed a work sampling study, a time study, a MODAPS analysis, and created SketchUp layouts of the workplace. Shown here is a layout of a typical NICU room. In order to set up the device, the respiratory therapist must walk from the table to the outlet in order to plug in the device, and then back to the table to retrieve the other components, and then go to the medical pole to set up the rest of the device. Here's a table that shows the current process steps for setting up the leak detection system. After completing 3 separate trials under the current state to set up the device, we have discovered that the location of the items makes the process longer than it needs to be. The process is not well documented as this device is not currently in place within the NICU, therefore that there is no standard process. And the greatest time in order to set up the device was 1, connecting all of the components to the bubble CPAP, and 2, walking between the table and the medical pole. Shown here is also our time study findings with a total time average of 80 seconds, and the MODAPS finding where the total mods are 412 mods. After reviewing the largest problems with the current state, we have developed a future state shown here in this layout. The biggest changes are, number 1, that there is a cart near to the medical pole so that the nurse and the respiratory technician have to walk less in order to assemble the device. And also, all of the parts will be assembled at the beginning of the process, further reducing the time to set up. The process improvements from the current state to the future state were, number 1, to create a new standardized process, and this would further reduce the time that the nurses will spend setting up the bubble CPAP device. For our time studies finding, we found a total time of 42 seconds, which was a 40% decrease from the current state, and the standard time per step decreased 51% as well. For the MODAPS, there were a total of 218 mods, and this resulted in a 47% decrease of time steps. We have created 2 different sets of recommendations for the future state, the first being process recommendations and the latter being design recommendations. For the purpose of this class, we are focusing mostly on the process recommendations. First, we are recommending that the standardization of the setup of the device, and this would increase the efficiency and reliability of the setup. Also, we are recommending to assemble all the parts at the beginning of the process, reducing the total amount of process steps, and to transport the device on a cart, thereby reducing the distance walked. This resulted from our time study in a 48% reduction in total setup time. For a design recommendation to the senior design team, we are recommending, number 1, that they fully attach all of the components permanently, reducing the total number of components from 7 to 1. We are also recommending that the device is packaged for easy retrieval of the device, and this would reduce the amount of clutter within the workspace. And we suspect that this would result in a 76% reduction in total setup time based on our work study. We experienced several limitations working with this project. Primarily, number 1, that there were limitations associated with working with this senior design project. We also were not able to do user testing with medical staff at the hospital because of time constrictions. This device is also a prototype. It has not fully been implemented and not fully been designed. And the MODAPS analysis may have had small gaps due to the large amount of steps within the process. For our future work, we plan to implement the design recommendations, interview and present setup to the hospital staff, and also develop documentation for a standard method. Thank you everyone for your attention, and now we'll open up the floor to any questions.